Welcome to my Switching, Routing, and Wireless Essentials course. This should be the CCNA version 7 curriculum. This is the second of 3 courses. How to secure remote access for a device. If we are looking at Wireshark and we're capturing data on the wire, and you try to telnet into a device, you will capture the username and password, plain text. That's because Telnet operates on port 23 and everything is sent in clear text. If we're using SSH will use port 22 and it provides a secure management connection to the device. Secure meaning it will encrypt the data. Meaning, if we're looking at Wireshark and we're actually looking at the connection, Wireshark should show it as a secured connection. What's really funny is when you're looking at this, what's being up on the window is actually the Telnet window, not the SSH window, because again, the password would be encrypted. So how do we make sure that our switch is able to handle certain commands? Well, first we have to make sure what version of iOS we're running. So if you're on a switch and you do show version, you can actually see what version of software we're running. Here we're running the C2660 LAN-based K9-M license, version number 1502 SE7. There is actually a video that I've previously done that will break down the licensing that will explain this better. The important part here is with the with the show version, it will actually show that it supports cryptography by the K9. The K9 after LAN base shows that it supports basic cryptography and encryption features. So how do you configure SSH? Again, we have a lab that will do this, but we have 6 general steps on configuring SSH. So the first step is you have to verify the switch actually is able to handle SSH. What you can do is look at the version, look at the cryptography settings to see if you can. Or a lazy way of doing it is you can actually do a show IPSSH command. The SSH command, if the device does not have the license for it, it will say it's an unrecognized command. If the device has the licensing for it, it will actually display a different error, but the command will be recognized. Step 2, configure the appropriate IP domain. That means configure the domain name of the network that will be using the IP domain name and the domain name global configuration mode within the global configuration mode. Step 3, we have to generate keys. Now again, the keys will be an RSA pair key and will be generating an RSA key automatically when you enable SSH. You can use crypto key generate commands to generate a new key. You can always delete old keys if you view that they have been compromised. Step 4, you have to configure user authentication. The SSH server can authenticate users locally or to a remote server like a Radius or AttackX server. Realistically, basic level, we're probably going to be doing a local user. And again, we create a user by doing a username space, the actual name of the user, space secret, and then giving it a password. Step 5, we need to configure the appropriate interfaces to accept SSH. So if we're looking at the VTY line, you have to enable SSH protocol on the VTY lines using the transport input SSH. Step 6, verify what version of SSH you're using. Enable SSH version 2, that should be done by default. The devices will handle both 1 and 2, but one has some vulnerabilities, so you don't want to do that. So you actually want to make sure you're using the newest version of SSH. And that is enabling SSH in a nutshell. Again, a lot of steps. We have a lab that will walk us through how to do this on a switch. How do we verify SSH is turned on? On a client machine, use a terminal emulator like PuTTY, and you'll do SSH. You'll SSH to the IP address of the device. When you actually do SSH, IP address of the device, hit enter, it should prompt you for a login. If it does prompt you for a login, you know the device is accepting SSH commands. Again, we have a lab that will let us check this. On the device, we can also do a show IP SSH, and that will actually show us the connections. Show IP SSH will show SSH version. Show SSH will actually show the connections. Again, here's the lab that we'll be doing. We'll be setting up a secure password, encrypting communication, and then verifying SSH. Moving on, we have our basic router configuration. Basically, same thing as a switch. You'd be setting up a host name, enabling a secret password, setting up the appropriate line interfaces, a line console 0 and the line BTY. Again, both routers, switches, same thing. We'll also be setting up secured passwords so that no password is left in plain text. That's what the service password encrypt does. And again, common initial configuration for both switches and routers. You also have to set up a banner, and you have to save it. I'm moving through this fairly quickly because I'm assuming you know how to do a basic device configuration. I've done other videos where I walk you through basic device configuration, so I don't want to spend that much time. Next, we have to talk about dual stacking topologies, meaning we have multiple logical addressing schemes, meaning we have both IPv4 and IPv6. That makes this a little bit more complicated, but it is totally doable now that we live in a dual IP world, meaning we have both IPv4 and IPv6. Globally, IPv6 is kind of taking over, but certain countries IPv4 is still really prevalent and IPv6 is still more of an infant. It's important to understand that for routing you should need at least one IP address by default. So either IPv4 or IPv6, but at least have one. Because within the Cisco realm, we're going to be looking at configuring mainly IPv4, but we're slowly going to be introducing more IPv6 configurations on all the devices. You have to turn on the interfaces. You have to have them activated, meaning you have to do the no shutdown command on the interfaces to turn them on. Optionally, you can also set a description on each interface so that you know kind of what they are. For example, here we have a configuration for gigabit 0000001 and a serial interface. So we actually will navigate to interface gigabit 000, give it an IP, give it a IPv6 address, give it a description, turn it on, and then we repeat for the other three interfaces. Again, we have to have at least one IP address assigned to it, and that's typically an IPv4 address. We also have what's called a loopback address, and a loopback interface is a logical interface that is internal to the device and is not assigned to a physical port. And it's considered a software interface and is automatically in a on or up state. The loopback interface is very useful when we're talking about testing and managing iOS devices because it ensures that at least one interface will always be available for connectivity. Like if we're looking at pinging something, this type of interface will always be up. You can enable and assign a loopback address by typing interface loopback, give it a number because you can have multiple loopbacks, and then apply a IP address like you normally would. We have a lab outlining how to configure the router, both for IPv4 and for IPv6. Last section is 1.5, verifying directly connected networks. Again, with this material, we are looking at directly connected networks and static networks. We're not talking routing protocols too in-depth in this course. So how do we verify? We have three main show commands: show IP interface brief, show run, and show IP route. Again, the show IP interface brief, we have both IPv4 and IPv6. Same thing with show route, with IPv4 and IPv6. When we do a show IP route, we have two types of items that will be connected. If we're talking directly connected, we have C, which is connected, and we have L, which is local. With the previous version, iOS, we only had a connected. They are slightly different, but they essentially mean the same thing for this course. Here we have a show IP interface brief. You'll notice it will list the interface and just a brief information about it. The interface name, address, is the protocol up. If we do a show IPv6 interface brief, again, it's going to show interface, its address, and its mode. Is it up status and is it up protocol? If the status is up but the protocol is down, typically it's an encapsulation issue. If the status is down or administratively down, it's because the no shutdown command wasn't issued. If we are looking at verifying individual links, we can actually navigate to the individual interfaces. So instead of doing a show IP interface brief, we would do a show IP interface and the name of the interface. Here we're looking at the IPv6 version of the interface, so show IPv6 interface gigabit 000. That will show that IPv6 is enabled. It will show the link local address. It will show if there is a global unicast address and the appropriate groups that it may have joined. Again, FE80 is a link local address, like a private address. A global unicast address is more like a public address. Normally, link local address interfaces are automatic. A global unicast address is not automatic. We also have the ability just to do the basic show run, and that will show the running configuration, and again that will be more general information because it will list the entire config. So it won't just be the IPv6 information, it will be both the IPv4 and the description. It will also show the duplex speed and actual speed that it will run at and more. And again, you can always do show interfaces. You can do a show IP interface, and you can do a brief or you can be specific. Another one is show IP route and show IPv6 route. Here we'll have our directly connected and our locally connected routes. This routing table will show paths between devices. The local host route has an administrative distance typically of 0 and has a /30 mask for a IPv4 or a mask 128 for IPv6. The local host route is for routes on the router that owns the IP address. Basically, it is used to allow the router to process packets destined to that IP. In a later video, we will actually talk about a color code breakdown of this, that we can actually understand the specific steps in each syntax used for the routing table. Moving forward, we also have a filter command. So you can do a show command, and you can also then manipulate it with a pipe. You can provide certain selection areas. You can include or exclude or begin in certain areas. Realistically, this is kind of outside the scope of a normal associate, but you can. All of this is going to be done through filtering expressions if you wish to. And I believe we have a lab that outlines how to do some of the filtering. We have a command history. If you ever programmed a Cisco device, you can modify it by looking at the show history, or if you're connecting using a terminal, the terminal should also have a history. You can also hit the up arrow or down arrow to look at commands that you've recently issued. And those are all part of the history feature set. Lastly, we have our third and final packet tracer that will help us verify both IPv4 and IPv6 network connectivity and troubleshoot connectivity, and I believe looking at the route table. Last module is our practice and our quiz. There might be an additional packet tracer or two after this, but this is the summary table. If you have any questions or concerns on this material, please reach out and I will get those answered. Thank you. Questions, concerns, please reach out. Thank you.